Hey there, and welcome back to another episode of chemistry. Today we are going to continue our study on organic chemistry. Specifically, we are going to be looking at macromolecules, and we're starting with carbohydrates. Carbohydrates. Okay, I know most of you, once you hear carbohydrates, it's eba that comes to your mind. Fufu. Okay, those are the carbohydrates that you know, all right? But there's a lot more to discuss about carbohydrates, okay? Apart from all of those, okay? Principally, we know carbohydrates they are very useful and they are used to store energy, okay? Do not forget that this tutorial is brought to you by the O3 Schools JAMB CBT Practice app. The app has all you need. It is fully equipped for your sure success in the forthcoming examination. All right, so let us see a question from the application, a JAMB pass question. This is a 2021 question, number 14. All right, it says here, which of the following is a disaccharide? Which of the following is a disaccharide? A says fructose, B says starch, C says cellulose, D says sucrose. Okay, so you don't know it, but of course you will know it at the end of this class. Okay, we'll come back to this question and many more at the end of the class, so please stay put and join us in the lesson. And do not forget also to download the O3 School JAMB CBT Practice app. It has all the past questions that you need for your exam for all subjects in one app, so you will not need to go and say you want to go and buy past question anywhere. Then two, there are lecture notes on the app that have been structured according to the JAMB syllabus. All right, so most of you study without using your syllabus. That is a big no. And then likewise, there are some wonderful features like the question search feature, there are educational games, and there's a bomb called the mock challenge. Okay, that mock is a challenge that will organize for all students that are writing JAMB for this year. Okay, in that challenge, you compete with your mates. All right, you get used to JAMB past questions, you get used to JAMB likely exam question, you familiarize yourself with the ways and manner that JAMB set their question, and then you see your result released every Saturday till 1 week to the main JAMB exam. So imagine yourself participating in as many mocks as possible and you are seeing your results. That means you're able to track your progress, because the mock questions are standard JAMB questions. All right, so please ensure that you stay put and you keep learning. All right, so please activation of the app is not up to the price of rice and chicken in a good restaurant, so please do not fail to activate. You can download the app on your Android phone, okay, from Play Store, or you can download it on your computer or your laptops. Okay, to download on your computer, simply visit o3schools.com/JAMB app and it will automatically download for you. If you are facing any issue with installing it for your computer, send a message to this number on WhatsApp 09121515246 and our customer care representatives will be there to assist you. So now let's talk about carbohydrates. Okay, carbohydrates. Earliest chemists, okay, those of the people that study biochemistry then, okay, earliest chemists, they used to call carbohydrates hydrates of carbon. They call carbohydrates hydrates of carbon. Okay, this is what they call carbohydrate. They call them hydrates of carbon. It remains to be seen why they thought, okay, that carbohydrates are known as hydrates of carbon. Okay, and this is why. Basically, we know glucose, right? Glucose is one example of a class of carbohydrates. Glucose is an example of a class of carbohydrates that we know as monosaccharides. Okay, we'll soon talk about the classification of carbohydrates. Okay, glucose is an example of a class of sugar that we know as monosaccharide. They are simple sugar. They are the simplest sugar that you can encounter. Okay, glucose has the formula C6H12O6. This is the formula of glucose. C6H12O6. It has 6 carbon atoms, has 12 hydrogen atoms, and 6 oxygen atoms. This is our glucose. Okay. Now, if you look for the empirical formula, okay, of this glucose, if you divide by 6, as you can see, 6 is common here, 6 is common here, 6 is common here, 6 is common between these three atom, carbon, hydrogen, and oxygen. So if you divide through by 6, what are you going to have? You're going to have C6/6. Okay, they are going to have your H12 over what? Over 6. You're going to have your O6 over what? Over 6. So 6, we cancel 6 here. 6, we cancel 6 here. 6 here, 1. 6 here, 2. So what I'm going to have? I'm going to have what is left here, C. What will be left here is what? Is H2. And what will be left here is what? Is O. Okay? So, and of course, this is what? This is carbon. And what is this one? This is what? It's water. And what does it look like there? It looks like what? It looks that what? It looks like exactly like what? Carbon plus what? Plus water. Okay, that is what? Now this is our glucose, which is also what? A carbohydrate. Okay, so from these simple analogies, it is not far-fetched why what earlier biochemists used to refer to as a carbohydrate as what? As hydrates of what? Of carbon. Okay, so carbohydrates are very, very important. They are very, very useful. That's why you see that whenever you eat a bar, okay, you see your belly all full, you get strength, okay? But if you say it's fufu, you want to eat, you want to load yourself with fufu so that you have power to do work. So as exactly as you debate that, glucose, carbohydrates are very, very useful. They are used to store energy. We use them to store energy. We use them to what? To store what? Energy. They are very, very useful, and we use them to store energy. Now, having known this now, it is also very, very important for us to now discuss the classification of what? Of carbohydrates. Okay, so there are 3 major classifications of carbohydrates. So I'm going to what? Look at them immediately. The first one, the class we call the simple sugars, or the simple sugars, single sugars, or simple sugars. They are known as the monosaccharides. So the classification. So we're talking about classification of carbohydrates. Okay, and of course we say that the first set, okay, the first class we're going to discuss are called what? The monosaccharides. Okay, and we'll say these monosaccharides, they are known as what? As simple sugars. Simple sugars. Okay, they're also called what? Single sugars. Okay, so we call them what? Simple sugars or single sugars. All right, so these are what? Monosaccharides. We call them simple sugars or single what? Sugars. Okay, we have some examples of what? Of monosaccharides. Example is what? The glucose we just talked about. So examples of monosaccharides we include what? We have your glucose. We have what? Your fructose. Okay, we have your xylose, we have your mannose, okay, we have your ribulose, okay, and what? And the like. So these are examples of what? These are all examples of what? Of simple sugars or monosaccharides. Examples are glucose, which we talked about, is one of the, in fact, glucose and fructose are the most popular examples of what? Of simple sugars that we have. Okay, so we have glucose, we have fructose, we have xylose, we have mannose, we have what? Ribulose, we even have galactose. We have galactose. Okay, these are all examples of what? Of simple sugars. Okay, they are the simplest sugars that you will encounter. Okay, these are all examples of what? Of simple sugars. Now, we also have another class of carbohydrates that we know as what? As disaccharides. Okay, we know this one as what? As disaccharides. They are called disaccharides. This disaccharide, the second class, disaccharides. Okay, these disaccharides, they are gotten, okay, from the combination of 2 simple sugars or 2 single sugars. Okay, so those are called what? They are called disaccharides. They are formed from the combination of 2. When you add two simple sugars together, you get what? A disaccharide. All right, so 2 single sugars or 2 monosaccharides, when you add them together, you get a disaccharide. Those are what? Disaccharides. So they are gotten by what? By the combination of 2 simple sugars. Okay, an example of disaccharide is sucrose. Examples are what? Are sucrose. Okay, and sucrose is gotten from the combination when you add fructose and glucose together. All right, so when you add glucose with what? With fructose. okay, you are going to get what? Your sucrose. All right. When you add glucose plus fructose, you get sucrose. So these are two simple sugars, okay, or two what? Monosaccharide. Adding them together, okay, gives what? Your sucrose. And you can also break down this sucrose, okay, into what? Glucose and what? And fructose. And there's an enzyme that helps you to break down what? A disaccharide into what? Two simple sugars. Okay, that enzyme is called what? Invertase. Okay, please take note of that. It's in your past question. Okay, I just remember I said I should just chip it in. All right. So this is an enzyme, it's a catalyst, okay, that helps the hydrolysis of what? Of sucrose into what? Of a disaccharide like sucrose into two simple sugars. So we are still discussing examples of what? Of disaccharide. The first one, sucrose, by adding what? Glucose and fructose. We also have lactose, number two. We have lactose. And this is gotten by adding glucose plus what? Plus galactose. All right. So we have lactose. For lactose, we add what? Glucose plus galactose to give us what? Lactose. All right. So please take note of that. Sucrose, glucose plus fructose. The two simple and most common simple sugars. When you add them together, you get what? Your sucrose. While for lactose, we get what? Glucose plus what? Plus galactose. Then likewise, we also have another one called maltose. You have maltose. Maltose, okay? And maltose is gotten by adding glucose plus another what? Glucose. Okay? So for maltose, we add glucose plus glucose to get what? Maltose. So two glucose, two simple sugars that are called glucose, okay? Two of glucose gives us what? Maltose. When you add glucose to glucose, you get maltose. When you add glucose to galactose, you get lactose. When you add glucose to fructose, you get what? Sucrose. All right? And we have said it here, okay? I've made it very important here that glucose and fructose are the most common simple sugars we have. All right? So those are what? That disaccharides that are gotten by the combination of two simple sugars or two single sugars. All right. So now let us go on to the third classification, and that will be what? Polysaccharides. From polysaccharide, we are talking, who is hearing polymer? Okay. So they are what? They are basically what? Polymers. Okay. Polysaccharide. Let's talk about polysaccharides. 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 Okay. So these ones, they are what? They are basically what? They are basically polymers. Okay, so a polymer is a long molecule. A polymer is a very what? Long molecule with what? With many monomers. Okay, so a polymer is a very long molecule having what? Having many what? Monomers. I'm sure that what? During the course of our study of organic chemistry, we have talked about what? Polymers. Okay, polymerization reaction. Okay, where two monomers, okay, will come together to form what? Polymers. All right. So basically, polysaccharides are what? They are basically what? Polymers. All right. They are made up of what? Of long molecules of what? Of molecules. Okay, long molecules of what? Of monomers. All right. So coming together. Example is starch and cellulose. Examples of polysaccharides, they are starch and what? And cellulose. Okay, these ones, they are examples of what? Of polysaccharides. Okay, they are what? Long molecule. Okay, with what? With many what? Monomer units. Long molecule having many monomer units. Long molecule having several monomer units. Examples are what? Are starch and cellulose. Okay, starch is what? Is found in what? In animals. All right, and it is used to store energy. While cellulose is found in what? In plants. Okay, starch is found in animals. Cellulose is found in plants. Take note of that. All right. So starch is found in animals. Cellulose is found in what? In plants. Okay. So those are examples of what? Of polysaccharides, starch and cellulose. Okay. Now we have talked about what? Glucose. All right. Seeing glucose and fructose, they are the most. They look like they are the most common simple sugar that we have. All right. So it is necessary that what we discuss about them in what? In details. Okay. So now for glucose has an aldehyde functional group. It is worthy of note that what? That glucose. Let's talk about glucose. Glucose, okay? Glucose has what? An aldehyde functional group. This is the structure of glucose, okay? So this is glucose. You have CHO, all right? Then you now have what? This 1, 2, 3, 4. Do not mind the way I'm remembering my drawing. This is the way I remember it to CH2OH, okay? This is the simplest way I use in remembering what my structure of what of glucose. So it has what the aldehyde functional group, okay? Then here we have what? H. Okay, here we have what? OH. Then here we have HO. Here we have what? H. Then here we have H. Here we have what? OH. Then here we have what? H again. Here we have what? OH. Okay, so there are two what? Projections. Okay, there are two projections of glucose. This is our glucose, and it has what? Two projections. One of the projection is called D-glucose. Okay, this is called the Fischer projection. Fischer projection of what? Of glucose. Okay, Fischer projection of what? Of Fischer structure of what? Of glucose. Okay, so and this glucose has two projections. One we call it what? D-glucose. The other one we call it the L-glucose. All right. Now, how do we differentiate between this D-glucose and this L-glucose? Okay, for the D-glucose, it is the most common what? Isomer or projection of what? Of glucose. Okay, D-glucose is the one that is commonly found, okay, in nature. All right, so take note of what? Of that. D-glucose is the most commonly found what? Projection of glucose in what? In nature. All right, now this is the D-glucose. All right, now the difference between the D-glucose and the L-glucose is not much. It's not very much. Okay, this is the structure of what? Of the L-glucose. CHO. Okay, the same 1, 2, all right, 3, 4. All right, then you have CH2OH here. This, we can see what at the top and the bottom are the same, okay? Having the aldehyde functional group here at the top. Now, the reason why this carbon, you know, here, there's a carbon here, there's a carbon here, there's a carbon here, there's a carbon here. All right, so please take note of that. So this point here, that carbon atoms are this what? Crosses. All right, this is just what the structure. Now, for the D-glucose, you see, we have what? Our H here. Here we have what? OH. Here we have our HO. Here we have what? Our H. Then here we have what? Our OH. Here we have what? Our H. Now, for this last one, for this last point, okay, you can see for the D-glucose, the OH is on the right. But for the L-glucose, the OH will be on the right, while the what? The H will be what? On the left. This difference between what? D-glucose, this one is D, this one is what now? This one is L what? Glucose. All right, so please take note of what of that. So there are two projections of what? Of glucose, which is what? The D-glucose, okay, which is the most common that is found in nature. And of course, this is what the projection of what? Of the L-glucose. This is how it is done. The difference is in the chiral carbon that is far away from this aldehyde functional group. All right, there's a chiral carbon here. Here, if you draw out only from here to here now, for example, if you draw out from here to here, okay, what are you going to have? I'm going to have your H, okay? Then I'm going to have here, on the other side, I'm going to have your OH. You know, here is a C. There's a C here that is bonded here. There's a C at this point. Then, of course, here is what? CH2OH. And then this one here is everything that is up here. Okay, so it's a chiral carbon because this carbon is directly bonded to what? 4 different groups of atoms. So the chiral carbon that is far away from the aldehyde functional group, the hydroxyl functional group is what? Is on the right for the D-glucose. While for the L-glucose, the hydroxyl functional group is on the what? Is on the left. And as you can observe very evidently, you will see that a glucose molecule has what? Several what? Hydroxyl functional group. OH group, almost everywhere. So we call this what? A polyhydroxyl what? Compound. Okay, it's a polyhydroxyl compound because it has what? Several hydroxyl functional groups. So that's how you differentiate between what? The D-glucose and the what? And the L what? Glucose. Okay, so now it's necessary to also note that what? The fructose, on the other hand, we don't talk about glucose, we talk about fructose now. Fructose has what? A ketone functional group. Glucose has an aldehyde functional group, while what? Fructose has a ketone functional group. Let's see. This is what your ketone, this is what your fructose now. Fructose. Okay, this is the drawing of the structure of your fructose, CH2OH. Okay, then here we have C double bonded to O, then we now have 1, 2, 3. Then this down here, CH2OH. Okay, so this is the drawing of what? Of your fructose. All right, so every other thing is the same. HOH, okay, OH, OH. Okay, this is what? Your fructose. Okay, this is the structure of your fructose. Okay, the fructose has what? A ketone functional group. Now, you see why for the glucose, the functional group, the aldehyde functional group was at the top, because when we're talking about aldehydes, we told that what? The aldehydes cannot appear, okay, at the middle of what? Of a chain. It can only appear as the first carbon. It can only appear on the first carbon. But ketone only appears at what? At the middle, or but ketone can never be on what? On the first carbon. So this is the first carbon. That's why I've seen this ketone functional group here on the second carbon. That's how I say fructose is what? Fructose has a ketone functional group. Take note of that. It should be an exam question. Ketone functional group. While what? Glucose has what? An aldehyde functional group. You must take note of that. So glucose, okay, glucose has what? An aldehyde functional group. Aldehyde. Okay, the functional group is aldehyde. But for fructose, the functional group is what? Is a what? Is a ketone functional group. Okay, so please take note that this is the structure. Okay, having what? 6 carbon atom. It has 6 carbon atoms. Okay, 1, 2, 3, 4, 5, 6. Okay, a glucose atom compound. Glucose has what? 6 carbon atoms. Fructose has 6 carbon atoms. They both have 6 carbon what? Atoms. Okay, and that is why we call what? Glucose. We call it an aldohexose. Okay, we call glucose an aldohexose. Aldohexose. Okay, whenever you hear the word OSE, okay, it means what? Sugar. We're talking about what? Sugar. Okay, whenever you hear the word OS, we're talking about what? Sugar. Okay, so now for us to say glucose, OS, sugar, okay, for us to say glucose is an aldo sugar, what does it mean? It means that what? It simply qualifies what? Glucose for you by telling you that what? Glucose has an aldehyde functional group from this ALD, okay? It has an aldehyde or functional group, and it has what? 6 carbon atoms, and it is what? OSC, a sugar. So, okay, so let me go over that again. It means that what? Glucose, if we say glucose is an aldohexose, it means glucose has 6 carbon atoms, hex. Okay, it's a simple sugar, and it is what? It has an aldehyde functional group. Why? For fructose, we say fructose is what? It's a ketohexose. Okay, meaning that what? Fructose is what? It's a simple sugar, okay, or it's a sugar rather, and then it has 6 carbon atoms, and it has a ketone functional group. Okay, so this is where we will round up as it pertains to what? To carbohydrates. Okay, we're not going to do more than that. It's an introductory class. In the next class, I'll talk about the preparation and the reactions of what? Of carbohydrates, and we are done with carbohydrates. But for now, let us go to the O3 Schools JAMB CBT practice app, answer some questions, and we'll be out of here. Now, this is a 2022 question number 35. 2022 number 35. It says, which of the following is not a sugar? It's not a sugar. I've seen a lot of sugars recently. So in this class, so please do know what form my hand. A says sucrose, B says fructose, C says saccharin, D say glucose. Okay, so obviously sucrose is a what? It's a sugar. It's a disaccharide. Fructose is a monosaccharide. Glucose is a monosaccharide, but saccharin is not what? A sugar. Saccharin is like an additive. It's a sweetener. Okay, it's a sweetener. But now let us go to 2021 number 14. 2021 number 14. It says, which of the following is a disaccharide? A say fructose. Fructose is not a disaccharide. Fructose is a monosaccharide. It's a simple sugar. B says starch. Okay, starch is a what? Is not what? A disaccharide. That starch is what? Is a polysaccharide. C says cellulose. Cellulose is also a polysaccharide. D says sucrose. Sucrose is a what? Is simply what? A what? A disaccharide. All right. So please take note of what of that. I've talked about what then. You say that sucrose is made up of what? Okay, we're taking it off the board. Say sucrose is what? Glucose plus fructose gives you what? Sucrose. Now, 2016 number 41. Don't to confuse you here. They say the ratio of carbon to hydrogen in sucrose. Okay, the formula of sucrose. Sorry, I didn't actually give you the formula of sucrose. Okay, sucrose is C12 sucrose is what? C12H22O11. Okay, so this is what your sucrose. Now, the question is saying the ratio of carbon to hydrogen. This is your carbon, this is what your hydrogen. They say, what is the ratio of what? Of carbon to hydrogen in your sucrose. So let us, that means they want us to what? To focus on carbon and hydrogen. Let us reduce the what? These numbers. Okay, we have what? C12, we have what? H22. 2 can go here 6, 2 can go here 11. So I'm going to have C6H11. Okay, that's 6 ratio 11. All right, so the ratio of what? Of carbon to what? To hydrogen there is what? 6 ratio 11. And option D will give us that correct answer. Okay, so 2005 number 12 again tells us that the enzyme responsible for converting sucrose into 2 simple isometric sugars. The enzyme responsible for converting sucrose into 2 simple isometric sugars is what? We said that it's what? Is invertase. Okay, A say maltase, B say amylase, C say invertase, D say lactase. All right, now 2000 number 50. They say sucrose is made up of what? I've talked about it, glucose and what? And fructose. That will be option what? Option B is very, very correct. Okay. So there are many other questions that border on what? On carbohydrates on the application. Go and download the OT School JAMB app today and start practicing your way to outstanding success in your exam. No worry. No, you say ba wahala when you have this app. Okay. Please like the video, subscribe to the channel, and share this video to your friends and loved ones, and see yourself succeeding. Thank you for watching. See you in the next episode.